Jinsang Kim told me he had some kind of super cool liquid. So I'm out here to ask him, what makes that liquid so cool? When Professor Jinsang Kim and his team first made the new molecule, they found that it could be either a liquid or a solid crystal at room temperature.
Initially, we designed this molecule as a building block for large conjugated polymer for solar cell application. And then the student Kyle just found that this molecule just stay in a liquid even much lower than melting temperature.
Now it is crystal form, which is solid. So if you see the fluorescence, it's a bright greenish yellow.
Typically, a liquid will solidify when its temperature drops below its melting point. But some materials can stay liquid even below their melting points. A material in this state is called a supercooled liquid.
So we will melt it, and this crystal won't come back to its original crystal form and just stay as a liquid even if it is cooled down to room temperature.
The material produced by Kim's team remains liquid over 200 Fahrenheit degrees below its melting point, which is pretty wild. The reason for this is that there was little driving the molecules to form a crystal structure. Most materials can release a lot of energy by crystallizing, which keeps them in balance with lower temperature environments. But for this material, the energy release was not very significant, so it often didn't bother to crystallize.
Even it is heated back to like a high temperature around 110 degrees C, it just still stays as a liquid fluorescence.
However, it did solidify with a little push.
So let me show you what we can do.
You just agitate the molecule, and then molecules start to form large enough nuclei and eventually crystallize. So that's why we call this the shear-triggered crystallization.
When the liquid is rubbed with a stylus, it forms crystals and changes from a dark red to a fluorescent yellow color. At room temperature, the crystals only appear where the liquid film is touched with the stylus, allowing you to write on it.
Why make this very unique property? But there are many interesting applications we can come up with. Now we are pursuing designing, developing sensitive biosensor. So we apply the cell on top of the liquid film, and this very small force by this cell sitting on the substrate can crystallize the liquid, and then it produces fluorescence.
Since the material has two states, fluorescent and dark, it could also work as part of a computer memory that is read with light. What started as an accident could have applications in electronics and even medicine. That's super cool.
Now we can do it with a single small chip that is driven by gravity. You can think of what we developed kind of like a gravity-driven fluidic computer that creates fluid flow that mimics a heartbeat. There's many drugs and therapies